All right, here we are on part B. We're going to talk a little bit about inference and sampling. Right, so the basics of inference are that we have to understand the ways in which inferential statistics work and fall down. We're going to use examples to get you through all this. All right, so let's say we had some sort of problem we wanted to address, looking at, does Sesame Street affect kids' brain development? So we can take that general statement and ask very specifically, is there a relationship between watching Sesame Street and test scores of a particular test that we would have to define? Okay, so this is something that can be addressed using inferential analysis that we've been talking about. So we're asking, is there some relationship between Sesame Street viewership and test scores? Maybe we have to define viewership in a very detailed way, like how many hours the kids would watch per week on average, right? And we have to define a test, like I said, the particular test score. And then we can try to explore this question. But how? What is this inferential statistics anyway, right? Well, it all starts with a population, okay? We have to have a large number of people in our population. And in this example, Sesame Street question, we would be saying the population of all children, right? We want to explore, what does Sesame Street do to children's brains without limiting ourselves to children in our city, say, or children who go to a particular school. No, we're asking this question about all children. We want to know, what does Sesame Street do to kids? Well, we're also going to need a sample of some sort, okay? So the problem is that in this example, all children is, something that's unobtainable. We don't know how to do things like ask every single kid in the world what their test score is and whether they watch Sesame Street. It's just not a feasible undertaking, right? So we can't actually know anything about this population of all children, except via the magic of sampling, okay? What we do is we take a sample from our population, and if we get the right kind of sample, then we can infer the answer to our question in the real population. Okay, if this sample here is representative of the population as a whole, then the things that we find to be true in this small sample should hold true in the bigger population. Okay, so we're going to look at Sesame Street viewing and test scores in this representative sample of children. And maybe what we're going to see is that if, say, 2/3 of kids were watching Sesame Street, then we're going to assume that 2/3 of kids in the whole population of all children also watch Sesame Street. Okay, that is this path here. So the forward path is we pulled a random sample from the population to be our sample. And then we work on the sample, which we can address feasibly. And then we infer that the results we find on the sample are also true in some way of the population as a whole. Okay? But the thing is that, right, we might have had this kind of thing here, or it could be this instead. We don't really know, right? There is random variability in how we draw our sample. There is random variability in the measurements that we get out of our sample. And so we know that there could be some random variability in our population that we're inferring. And all these techniques do is they try to quantify that uncertainty. They try to take this random variability of this or this, and put a number on it. And we say that we're pretty sure it's going to be between this and this. Somewhere in this range is what the answer is going to actually be. Okay? So how does this happen? Well, again, we have to sample the population. And if we don't sample the population well, we're going to get a bad answer. But even when we sample the population well, we know sometimes we're going to draw this, and sometimes we'll draw something else. It's just random chance. Okay? Now, and again, like I said, if your sample does not represent your population, right? If there's this whole new category of kids who only watch Sesame Street at their grandmother's house once a week and never get to watch it at their parents' house, right? Then, and if we don't get any of those purple kids into this sample, then we're not going to be able to make accurate predictions of the whole population because we're missing an entire class of subjects, right? So let's give another example. Here's a paper that was published in a scientific journal which talks about the effects of air pollution on life expectancy. Okay, they're doing an analysis of 545 U.S. counties from 2000 to 2007, looking at relationships between air pollution levels and life expectancy. So, this is the question. Is there a relationship? If so, what is it? So let's try to look at this from the standpoint of sample and population. What is the population in this question, right? What are we trying to understand? We're trying to understand how air pollution affects Americans, right? Every single one of us. So obviously we can't do measurements on every single American, all 375 million of us or whatever it is now, right? So instead, this paper takes a convenient sample, 545 counties in the U.S. Okay? I'm not sure how many counties there are in the U.S., but there's definitely thousands and thousands. So another way in which we could look at this, another kind of question is, if we have a statement that Girl Scouts were randomly sampled from across the United States, what do you think the likely population would be? Yeah, you with the purple shirt. Okay, so you think that Girl Scouts sampled randomly across the United States, you think that the population would be all girl children? Well, I think there's something missing from that answer. Okay, so you notice the part where it says they were randomly sampled from across the United States. I think that indicates that we are interested primarily in girl children across our country and not across the whole world, because there are some really strong differences between Americans and people from, say, Venezuela. Okay? All right, so I hope that these exercises gave you a sense of what it means to have a population and to pick a representative sample that will give you some sort of ability to infer things about that population. All right. So the next thing that I want to do is we're going to talk about these 4 ways. Really, I'm going to chat about 3 of them today. These 4 ways in which we can do inferential analyses. All right. So I'm going to kick us into another part of the video. Just try to break this up and keep it more fun. So I will see you all on the flip side. Bye.